1 o'clock East Coast, 12 o'clock Central, and then the morning for the rest of the US and Canada. Good morning and good afternoon. My name is Bill Glowacki, and I'm the VP of Sales here at Vivid Supply. And we welcome you and thank you for joining our webinar. Vivid Supply is a trusted PPE supplier, and we appreciate the opportunity to provide you with education and insight regarding evaluating exam gloves for your health system and need. I'm joined today by our glove product manager, Justin Giulio. Justin, would you introduce yourself?
Yeah, thanks, Bill. I'm Justin Giulio. I am the glove product manager. Been in the glove business for nearly 6 years now. So lived through the ups and downs of the pandemic and getting access to sourcing glove supply. And I'm looking forward to teaching you all some of what I've learned over the last 6 years.
Justin, thanks. So I'm going to begin with a brief introduction of Vivid Supply, and then I'll hand it over to Justin, who will go through most of the content. So think of me as your appetizer to this meal, and Justin is the entree and the dessert. He'll be providing most of the content here. We will have some time at the end for questions, so feel free to add your questions to the Q&A box along the right-hand side of your screen. And if you run into any technical difficulties, please leave a message in the chat, and a member of our team will help you and assist you, make sure you get your question recognized. So on to Vivid. Vivid Supply is the biggest PPE provider you've never heard of. We provide 1 in 13 exam gloves used in North American hospital. That's over 2 billion, that's with a B, 2 billion gloves per year. Backed by 30 plus years of high quality self-manufacturing from our parent company, Primed, we focus exclusively on what we do best: gloves, gowns, and masks. We forge strong partnerships with health systems to provide cost savings, supply assurance, and clinical reliability. And with that, I'll hand it over for the entree to Justin.
Awesome. Thanks, Bill. All right, so we'll start off with a few of the basics. Just start nice and easy with exam glove materials and characteristics, and some of the raw material characteristics of different types of gloves. So 3 different types of gloves I'm sure most have heard of is nitrile, latex, and vinyl. So we'll walk through the advantages, disadvantages of each type of glove, what makes them good and bad, etc. So starting off with barrier protection, nitrile and latex both have fairly strong barrier protection, a good resistance to punctures and tears, whereas this falls off a bit with vinyl. So vinyl is the weakest of the glove materials. So low resistance to punctures and tears. If it's tested in any kind of way, it usually ends up ripping. In terms of strength, similar here, latex does have a slight advantage in terms of physical properties. So we'll talk about different things like tensile strength, elongation, modulus. These are words we'll go into in coming slides, but they're in essence physical properties that make a glove perform good or bad. So latex has the best physical properties. Nitrile fairly close, performs very well as well. Vinyl again dropping off, not having well performance towards any of these physical properties. Transitioning to fit and comfort, same story. High elasticity in nitrile. It's good for hand fatigue. It's very form-fitting, comfortable. Latex does have a slight edge here as well. It's very second skin-like, very comfortable glove to wear. Where you start to see a disadvantage in latex here is latex allergies have become common in clinical settings, developing over the last 15 or 20 years. So that's been, a huge down draw to using latex material, although it does have good physical properties. As you move into vinyl, again, falling off here in terms of a disadvantage, it has low elasticity. It fits loosely or tightly, depending on, whether or not you can squeeze into a certain size or not. You'll have some parts of your hand that feel snug and some parts that feel loose, which ultimately doesn't, lead to good tactile sensitivity or comfort throughout your day. Chemo and chemical resistance. Nitrile, again, having the clear advantage here. It's resistant to many chemicals, chemo drugs, solvents, many different things you'll find in practice. So in that sense, it's great. Latex has limited chemical resistance, limited chemo resistance. You will find certain gloves that have some type of breakthrough time supporting them, but they're often much thicker latex gloves, which are not as form-fitting and quite expensive in practice as well to get those types of gloves. Vinyl, even further down the spectrum, has very low chemical resistance. Even common organic solvents, oils, greases, organic stuff like that will break through vinyl gloves fairly easily. Price, last but obviously not least, a very important thing for a lot of health systems. So nitrile, as we've seen in practice, is the economical choice. It's a great blend of advantages of all the rows above for all areas of the hospital. Latex, like I said, has allergies. It has good physical properties, but it is actually a higher cost, and there's often more volatility with latex costs, given that it's derived from latex trees, and that market can be fairly volatile. Vinyl is the winner here in its first win of all the rows. It is the lowest cost, but we recommend that it should be used only in low risk situations, which obviously isn't a huge portion of the hospital or health system. And in terms of price, there really hasn't been that much of a jump lately between vinyl and nitrile. So you gain all of the advantages above with a very reasonable price premium to vinyl. So that's why you can see a shift in glove material. So I'll move on to a chart that kind of illustrates what I've been talking about and shows, real data in the US market and how this has changed. So in 2007, you'll see nitrile, vinyl, latex, each own about a third of the market. Vinyl was pretty cheap. Nitrile was fairly newer to the scene, still, not as efficient to manufacture. So you've seen that, they each kind of had a split. There wasn't a lot of clinical allergies to latex. So each of them owned a fair portion of the market. As you shift towards 2013 and then 2023, which is where we sit currently, you can see how nitrile has gained a significant share of the market in terms of usage. So we're sitting today, depending on the health system, it does vary. I'd say 90 to 96 to 98% nitrile in certain cases. Nitrile's become a lot more specialized. You can have longer, shorter, sensitive skin types. There's much more innovation within nitrile. So it's really been a good, economical, reliable option without those clinical sensitivities to latex and allergies, which has really driven latex out of the market in most cases. This is just exam gloves. I'll say that there are still quite a bit of other materials in surgical cases. We're going to focus more on exam gloves today. So if any of this might not make sense in terms of surgical gloves, that is true. Latex does have some specialty usage in surgical side as well. So I'll note that. All right, so talking about a little bit more of the technical features on gloves. There's three main categories that you use to assess the physical properties that I mentioned previously on gloves, and they're tensile strength, elongation, and modulus. So starting with tensile strength, this is the measurement of the amount of stretch or pull required to rupture or break the glove material in a shear force measurement. So the higher the tensile strength, the stronger the glove material. Pretty simple. Moving to elongation, this is a percentage of the length that the glove material can stretch before it breaks. So the higher the elongation percentage, the more elasticy the glove material feels, more form-fitting, that type of thing. So they're not stretching necessarily a glove in the test. They're taking a small strip of the nitrile material or vinyl material or latex and stretching it with basically two prongs and seeing how far that little strip of glove material can stretch before it breaks. Modulus is one that doesn't really get talked about as much, but it's still a very important characteristic. So this is the measurement of the amount of resistance to stretch. So a lower modulus value represents a glove that's easier to move and less hand fatiguing. So if you've ever had a glove material on that is a little bit thicker, you'll notice that you put the glove on, and if you let your hand relax, you can feel the glove basically close your hand. So throughout the course of a day, a clinician is in essence fighting the material of the glove as they open and close their hand, doing periodic tasks throughout the day. So if you're wearing a glove that doesn't have a good balance of these physical characteristics, a high modulus, it might be more protective because it's thicker, which is necessary in certain cases, but it is quite hand fatiguing by the end of the day to be fighting obviously that nitrile, and it can lead to fatigue on back-to-back shifts and stuff like that. So We recommend, paying attention to these characteristics and, understanding which is best in certain situations, as they're not a one size fits all. So again, diving into the data, just to show you a bit of how this has changed over time. This is nitrile attributes, showing you how they've changed since the early 2000s and where we're at today. So as you can see, elongation, tensile strength, modulus, those things we were talking about have all trended in a positive direction. So elongation, tensile strength have both gone up, which means, that's good. They're getting more stretchy, more elastic, more form-fitting. And modulus is actually the inverse. As modulus goes down, you get a glove that's, more resistant to, or less resistant to stretch. So all of those are trending in a more comfortable direction in practice, while you can see the gram weight of the gloves have actually gone down. So why that happened is because as manufacturers got better at manufacturing nitrile, they were able to make manufacturing more efficient. The formulations got better. They were able to blend the raw materials that make up gloves to ultimately make them better performing for less weight, which ultimately means less input raw materials, more efficiencies, lower costs. Generally making better gloves overall for the health system. So this is a big piece of why nitrile has taken over a lot of vinyl, is because the gloves have gotten better and the actual input materials have gone down. So you get a better performing glove at a lower cost. So in practice, a lot of vendors like ourselves will provide testing tables on how these characteristics land actually, on the testing side of things. So ASTM D6319 in the orange second column basically sets a baseline for exam gloves. This is specific to nitrile, this standard. And it basically outlines how these characteristics should look at a bare minimum. So that's definitely not the standard. As you can see here, we have 3 different glove examples, glove A, B, and C. If you go through them, you can see how each of them actually exceed the standard, which is very normal for glove manufacturing. If you see gloves that are down near the standard, it's definitely I would say below average performance for the market. A lot of glove vendors seek to exceed these standards, and you should definitely look for that when you're paying attention to a lot of these physical characteristics in sourcing gloves. You'll see unaged and aged. So this is just a test to see right off the line, gloves are fresh, they perform differently. So they're hotter, the glove material takes quite a bit of time to cure. So right off the line, they'll test these gloves. They're often stretchier right off the line. So the threshold is a bit higher when it's unaged, just to make sure that the gloves are exceeding that. And that's why you'll see the number shrink. Elongation, for example, shrinks to 400%. After they age, they set a little bit, they get a little stiffer. That would be obviously all set by the time it gets to you at the end user level, but just an explanation of why they do unaged and aged testing. There's a bit of, I don't want to say games that get played here, but it's good to pay attention to these things and make sure vendors are exceeding these things. Although there are these baselines set out by the ASTM standard, there are certain places where there's room for differences. So thickness is sometimes advertised at the finger, for example, when there is thickness at the palm. And the reason that a glove is thicker at the finger is because the way they're dipped at the manufacturing facility is basically finger down. So there's a hand former that gets dumped in a liquid nitrile tank, for example, gets lifted out, and it's a liquid solution that cures top down. So you can imagine there's a bit of a run happening, not much, but it causes the fingers to actually be the thickest portion of the gloves because they're at the bottom of the hand former that comes out of the tank. So you might see someone advertising a glove with one type of thickness, and ultimately that's not the case in practice. There's a thickness at the fingertip, there's a thickness at the palm, and there's a thickness at the cuff. The ASTM standard only outlines thickness at the finger and palm, as that's really what's impacted in practice. You're not necessarily handling things with the cuff of the glove, but it's a good piece of information to pay attention to if someone's advertising the thickness of the glove. So the length of the glove in practice is actually up around the 240 to 250 millimeter range, whereas the standard is only 230. So it's good to pay attention to what length of a glove you're getting. Someone may be proposing a glove that is near the standard, trying to trim a bit of that cuff down to save a little bit of cost. So if you get a glove that's 230, when in reality your glove is actually in the 240 to 250 range. So I'll get into a bit of how to look at that later, but it's just good to pay attention to obviously the standard and then what are you actually getting in practice, because a lot of vendors like ourselves try very hard to exceed these standards and provide better gloves than the baseline. In terms of AQL, this is something I'll go into in its own slide. It has its own depth of testing, but this is basically acceptable quality level. So this is the amount of defects that are allowed in gloves. Obviously, they're mass-produced commoditized items. It's unrealistic to think that every glove will be made perfectly, although we strive to do that in this business. But you'll see vendors will push that AQL level down to 1.5 or 1.0, which is actually better than the standard. So it's good to know, just a gut check on where your gloves are being manufactured. The slide I go into later will show the scale of how that might impact your facilities. All right, so we'll transition after the exam glove basics into some common misconceptions with gloves in general, and what to pay attention to and what's real and what's not. So first of all, thicker material equals better. And this goes the same the other way, thinner material equals better. Thinner or thicker nitrile doesn't automatically mean better protection or less or more hand fatigue. What you're looking for is balanced physical properties, balanced formulations, consistent formulations in manufacturing, chemical and chemo resistance that has a depth of support in chemicals and drugs, and not just sheer mill thickness. Overly thick gloves can reduce the dexterity and increase hand fatigue. And on the other end, if you have a glove that's too thin, obviously it's very hand fatiguing, but the puncture resistance falls away. So you can see by the graph before, some people may still feel that a thicker glove is just better all around. Not necessarily the case. If you can really dial in as a vendor, sourcing, manufacturing that is a good balance of gloves at a certain gram weight and mill thickness that makes sense for the end users and really understand what they're being used for in practice. It's really important to pay attention to that. And thicker or thinner doesn't necessarily mean better or worse. Secondly, same glove spec equals same experience. Not the case. So nitrile gloves vary widely in durability, stretch, pinhole rates, like I mentioned in the previous slide, with all those different characteristics. You might see a glove that weighs the same on a scale, looks the same color, same amount of gloves per box, that type of thing. But actually, when you use it in practice, it's very different. So looking at gloves on spreadsheets is not always the best way to assess whether a glove actually performs better in practice. There's a lot of things that go into making gloves behind the lines. So actually touching and feeling samples that are going to be used in practice is a critical part of assessing gloves for your health system. Things like layering in the box, the chlorination of the gloves. So gloves are chlorinated. It's an evolution of powdering, basically to help the donning efficiency of a glove. These are things that don't get tracked and don't get necessarily benchmarked as part of the standard. So looking at gloves in practice and assessing the performance of the gloves physically is very important, because the same spec on paper does not necessarily mean you'll get the same glove when you start using it. So all vendors manufacture gloves. This is a big misconception, big or small. Even the biggest manufacturers in North America don't manufacture their own gloves. They source from third-party factories with varying levels of quality control. There's a lot of vendors over in Asia that manufacture gloves. Further to my previous point, this means that two gloves that look similar do not necessarily perform the same in practice. The reasoning for this is different factories excel in specific types of gloves. So whether it's general purpose or specialty, a certain manufacturer will get really good at making these gloves. And glove lines are significant investments in real estate and financially. And in order to justify the cost of these machines, they need to run billions and billions of gloves consistently with the same formulations to really dial it in and make consistent quality gloves. So to have a full health system, so at a hospital level, you might have thin gloves, thick gloves, extended cuff gloves, gloves for people with skin sensitivities, a whole basket of gloves that make up the purpose of what you need in practice. So basically, you need to source from a basket of manufacturers as well to make sure you're getting the quality gloves that that manufacturer focuses on. So they each have a few that they really make their bread and butter, and they really focus on being really good. So a certain vendor might make blue extended cuff gloves all day long, every month, consistent manufacturing, and they're really good at dialing in the quality of those gloves. So as a vendor in Vivid Supply, we seek, visiting factories. What gloves are you good at making, to cater and put together a portfolio of the best quality gloves in North America. So a vendor that's not necessarily as good at this is where you'll start to see quality disadvantages come through, because they're not necessarily sourcing from some of the manufacturers that are, incredibly good at making gloves every month, and they've been doing this for, 30 or 40 years. So last one being nitrile coatings solve skin health. So nitrile coatings are liners. You'll see aloe vera, collagen, oatmeal, different types of coatings solve skin health. Not always the case in solving what's skin health at the end of the day. So a proactive approach to hand dermatitis that's not fairly commonly spoken about at the end user level is accelerators. So basically, what's causing sensitivities in some nitrile gloves, I'll say it's a very small percentage of people, but it does happen, is the accelerators that are used in the manufacturing process of nitrile gloves specifically. So they're chemical agents that are used to cure the gloves on the manufacturing line. It's used to bind the material. However, it doesn't really provide a significant advantage or disadvantage when you remove them. So if you remove those accelerators from the glove, that actually stops the dermatitis potential at the start and removes the problem before it begins, instead of putting coatings like aloe vera, collagen, oatmeal on the glove to soothe those after it happens. The best analogy for this is the sun. Basically, if you're going to the beach and you want to avoid a sunburn, or avoid hurting your skin, getting a gazebo or an umbrella and staying out of the sun directly completely would remove the chance of a sunburn, instead of laying in the sun and putting aloe vera on your burn afterwards, is the best analogy I can use. So removing those accelerators from the manufacturing process would reduce skin sensitivities. And like I said, not a problem with the vast majority of people, but those that do have sensitivities to nitrile, skin coatings for gloves is not necessarily the best solution to this problem. So we'll move into testing standards and quality levels. These are specific to nitrile, as they own most of the market. So ASTM D6319, we touched on this in that table of physical properties. This is the standard specification for nitrile gloves that sets out those characteristics we talked about previously. So I won't spend too much time there. ASTM D6978 is the standard you should recognize for all chemotherapy testing on nitrile gloves, gloves in general. Basically, this sets out a certain number of drugs that are needed to be tested on chemotherapy drugs, and the base minutes that they should be tested for, which is 240 minutes. Up until a maximum of 240 minutes, sorry. And then we have ASTM F1671. So this is a test for viral penetration. This is a pass or fail test. It should always be passed on nitrile gloves. So that's something to look for as well. And then ASTM F739 is chemical testing specifically. So unlike the chemo D6978, F739 does not set out a specific list of chemicals that you need to test. It basically just sets a test method for testing against chemicals. So there is no real baseline, but I'll get into what to expect from these chemicals in the coming slides, these standards in the coming slides. But these are the base standards that you should look at on your nitrile gloves that should be met and often exceeded in many cases. Alrighty, so exam glove quality. Ultimately, like I spoke about, variances in exam glove quality do not start and stop at the manufacturing line, although that's very important to source from manufacturers that really dive into quality. That is an integral part of the process. There's much more like suppliers and vendors in terms of Vivid Supply can do outside of the manufacturing line to make sure that quality gloves make it to the end users. That starts with facility qualification. So social responsibility audits are super important, making sure in certain facilities that there's no forced labor going on, there's good labor practices in general, employees are being treated well. Industry reference checks, who are manufacturers making gloves for? Are they flowing into the North American market? And what is their loyalty in terms of jumping around getting volume? Are they just looking for the most volume wherever they can get it, or are they looking for loyal relationships, which is very important, not in the day-to-day, but in terms of emergency during the pandemic. Having loyal relationships with a facility, and a facility that values loyal relationships, is critical when you get into situations where supply is tight, usage goes through the roof. Having loyal partnerships ensures continuity of supply in terms of supply and demand spikes. So product alignment wise, analyzing the product portfolio, strengths and capacities. This is a bit of a lead into what I was talking about earlier. Different manufacturers are very good at making specific types of gloves, and they have their own basket. So analyzing whether their portfolio makes sense with the customers that you supply as a vendor is very important, and making sure they have the capacities to take on the volume swings that might come from different health systems within your portfolio. So further to that is providing transparent testing documentation. So there's a certain part of the process that manufacturers test. They do their own quality testing. They do a bit of chemical testing and a bit of chemo testing as well. Taking that into consideration is very important. But obviously, like I said, there's much more that goes on behind the scenes with the vendor doing their own testing and quality benchmarks as well. But making sure that the manufacturer is doing that stuff off the start is a very important piece. In-process inspection. So consistent line speeds, formulation, automation, layering, and packaging. These are all things, again, that don't get captured as part of the standards, but are very good to pay attention to as a vendor. So you're not just handing over the keys to the manufacturer, accepting containers of gloves, and that's it. There's a lot of things that go on in terms of site visits. Vendors should be having regular site visits with their manufacturers, getting an idea of how they're increasing automation, efficiencies, layering the gloves properly, making sure they're not balled up in the box so you're not pulling out 10 at a time, that kind of thing. Testing the gloves that are actually coming to you off the line leads into pre-shipment inspections. So the manufacturers do certain testing, but they're not necessarily testing the gloves that are exactly going to you. They're doing mass manufacturing lot tests on a glove manufacturing line, and then sending obviously chunks of what comes off that line to different vendors. So doing retesting on the actual gloves that are headed to you and not just random sampling, relying on that from the manufacturer's end, is also a critical piece. So having quality points that span before the gloves are made and while they're made, and analyzing the gloves that are coming to you, is very important to make sure that you dial that quality level up a little bit more. And then post-shipment inspections is also very important. So once the gloves get loaded into a container and put on a truck or ship, ensuring that ocean freight or ground transport did not negatively affect the gloves. Obviously, they go through, across the ocean, there's temperature swings, different weather in different parts of the world. It's important to make sure that that weather and temperature swings did not negatively impact the gloves before they get to the end user. So that's another key piece to make sure that a vendor is paying attention to. So here's an expansion of the AQL level, acceptable quality level, that I mentioned previously. This is just an example to show you how this actually ripple effects into practice. So this example looks at an assumed mid-size facility. Let's say the facility is purchasing 50 million gloves per year. So you can see the acceptable quality level of 2.5, which is a statistical reference, not necessarily the 2.5 translating to the amount of defects or anything like that. That is the exam glove ASTM standard. Basically states, if we test a certain lot of gloves based on average manufacturing lot sizes, at this facility level, that would translate to 2.1 million allowable defective gloves, which sounds a lot in practice and actually is not what happens, but this is an extrapolation for an example. So if you were to extrapolate the amount of defects that are allowed in that lot at that average manufacturing size, it ripples up to 2.1 when you start buying 50 million gloves. So as you reduce that as a vendor to AQL 1.5, you're taking essentially 700,000 defective gloves out of rotation, dropping that allowable defect level to 1.4 million allowable defects, And then further on to AQL 1.0, you see how that drops again to 1,400,000 less defective gloves. So like I mentioned, at this level of manufacturing size, there will be certain defects that get pushed through on gloves. Although we try our best to even manufacture gloves below AQL 1.0 at the next level, which is 0.65. These are some of the numbers you'll see in practice that are more common, and not necessarily saying that, you'll get 1.4 million guaranteed defects if you buy that many gloves. But this is just an example to extrapolate, what that looks like in practice. And a lot of people don't talk about AQL levels, but it's a very important piece of sourcing and something all vendors should be paying attention to and trying to pull down. Alrighty, so chemotherapy and chemical testing, bouncing back here. This talks a little bit more about the testing standards in detail. So this is basically what the standard lays out and what to expect, because it's very different, like I mentioned, in practice. So chemicals, I have 20 written on the standard here. Like I mentioned with F739, there's no baseline specific chemicals that it tests to, but I put a standard here. For the most case, you should expect a baseline of about 20 chemicals tested to a glove. Or not expect, that's what you'll see in practice. Whereas what you should expect, it's very reasonable to see, greater than 50 chemicals tested to a glove that's used at a high volume. So the gloves that you're using with chemical handling for many parts of the hospital should be tested to over 50 chemicals. And then chemo drugs, so the D6978 standard, it does outline that there's 11 important drugs that should be tested on all nitrile gloves, which includes some of the ones listed in this picture on the right, mainly carmustine and thiotepa are the two very important ones that need to be tested that often do have a breakthrough time associated with them. What you should expect in practice, the 11 are not where this testing stops. You should expect over 50 chemo drugs tested to a nitrile glove that is used for handling chemo drugs. On this, you'll see different gloves. Obviously, gloves that are thicker, like a 3 mil type example glove, may have up to 50 chemo drugs, whereas you'll have up to 6 mil gloves used in hospitals. They also have a lot of chemo drugs tested, and you might think that, okay, that's great. They're both tested to the same amount of chemo drugs. They both should be equivalent in terms of breakthrough. Not the case, obviously. As the thicker material comes into play, you get major advancements in terms of breakthrough times, and there's variability within this testing. So if you have a breakthrough time that is, let's say, 8 minutes versus a breakthrough time that is 80 minutes, there's a bit of variance that happens there within this testing. It's a one glove at one point in time testing. They might test 1, 2, 3 different gloves to get an average for the breakthrough time, but there is a certain amount of variance that happens. So if you're at 8 minutes and you have a bit of variance, that can mean you might slip down to 5 minutes, or you might, push up to 13 minutes of breakthrough time. But that does vary. So paying attention to not only the amount of drugs, but the breakthrough times is also very critical. And then fentanyl is something that is tested to the chemo standard, but not outlined as a necessary drug. But this is something that should be expected to be greater than 240-minute breakthrough on all nitrile in your portfolio, from thin to thick. Fentanyl protection should be a standard. On the right here, I'll talk about this picture quickly. So this is the picture of a back of a box. They should be clearly labeled so clinicians can easily identify important testing information. Literature support should be provided and easily available. And then additionally, there's almost always more testing available. So you can only fit so much on the box in certain cases. And we try to cater this to where these environments are being impacted, whether the gloves are intended to be used around chemo drugs and recommended in different cases. Depends sometimes on what you'll see on a glove box across multiple vendors. So if you're not seeing what you need in terms of a chemo drug, don't be afraid to ask a vendor, do you have more testing in the background? Can you send me a list of what your chemo testing or chemical testing literature looks like? There's often almost more behind the scenes there to look at. In terms of the current market, obviously a lot of things going on, so I'll try to touch on where the market sits today and what to look for. So turning back to 2020, there was an emergence of a lot of new manufacturers. Exam glove consumption doubled during the pandemic, which obviously made opportunity for a lot of different vendors enter the market. supply heightened, demand could not quite be met. So that means there was, new manufacturers with little to no experience, and resulted in lower quality in the market, which I'm sure has been known across many people in this call. So lower price points in the market, reflective of the quality. Obviously, with a boom in capacity, there's been, on the flip side of that, as we move out of the pandemic, a lot more capacity. So that's pushing price pressure. Some manufacturers are getting pushed out of the market. It's the ones that really have, those quality advantages, consistent, loyal relationships. Those are the ones that are sticking around. But there is, has been an excess of capacity in terms of glove production over the last few years. That has been slowly shrinking back to normal state. Geopolitical uncertainty, obviously the news, there's lots going on these days. Tariffs are a buzzword that has been talked about, obviously a lot over the last year. They've continuously shifted supply and demand. So basically how this impacts US glove purchasing is tariffs have come in on Asian countries, China, Malaysia, Indonesia, Thailand, different countries that are good at manufacturing gloves, and that's shifted things around. And what that means is vendors have had to be very agile with their sourcing practices, making sure that the vendors you're partnered with have sourcing legs across multiple different countries to ensure if a tariff comes into play, that they are able to shift manufacturing around to ensure that a very limited, if no price increases end up getting to the clinical level. What this has done on the backside is put high pressure on manufacturing to become more efficient and or unique. So there's different levels of tariffs. The countries that have higher tariffs have been trying to become more efficient, obviously, to remain competitive. And the countries that have gotten more of the business due to the tariff fluctuations are trying to become more unique, trying to innovate. And that feeds into my last point here, which is different types of innovation that we're seeing on gloves recently. So the first one being glove innovation at its core is better formulations, increased testing support, sustainable solutions. So these are innovations that are purely based around the product, which I'd say have slowed a bit. You do see different things like accelerator-free gloves, biodegradable gloves, which are great new advancements in the market and things to pay attention to. And then surrounding the glove, there's packaging innovation. So this has caught a lot more speed lately in terms of the dispensing efficiencies and reducing waste. Obviously, at the scale of some of these facilities, purchasing gloves, reducing glove waste has been very critical. So this is accomplished through the way the gloves are layered in the box. Having consistent layering leads to easy one-by-one glove dispensing, and box designs with film or different perforations can make really meaningful impacts to the way you interact with the glove and the way gloves dispense out of the box, and making sure that multiple aren't falling out, hitting the floor, that type of thing. And then thirdly is business innovation. So this is a lot of what happens in the background and not necessarily communicated as much to the clinical and purchasing levels, are increased importance on manufacturing automation and vertical integration. So this means reducing the amount of hands that touch the gloves, automating the processes and manufacturing lines from front to back, materials to packaging, logistics, warehouse support, all that stuff, trying to automate as much as possible with obviously oversight by human labor to make sure everything flows smoothly. And then vertical integration, so owning the raw material production of the gloves, making sure you're getting quality raw materials from front to back, packaging support. If you need to ramp up production, you can get access to package support quickly, those types of things. So that's where you've seen a lot of innovation in gloves since the pandemic. So US domestic manufacturing is another thing, part of the current market. Out of the pandemic, obviously, it was hard to get gloves. So talking about US domestic manufacturing has been a bit of a buzzword as well lately in the previous years. This is, in a reality, what that looks like right now. Only a handful of domestic facilities operate at a meaningful scale. It's great that we're manufacturing gloves here, but the ability to support the North American market with US domestic manufacturing the gap is quite significant in terms of if we were to get into a state of emergency or increased pandemic supply, the US domestic support would not be able to support COVID-19 levels, and that would be maxed out pretty quickly. The key constraints here are high labor and utility costs to make competitive production. So obviously, a lot of this is automated and more automation every year, but there are still labor costs associated with this. Handling the gloves in terms of logistics within the manufacturing facilities, the quality checks that happen, those all are done by obviously real people. So that all feeds into the cost of managing a facility. Limited access to raw materials. So a lot of these raw materials are actually imported from outside of the US. So there's a reliance there on raw materials that are made outside of the country. And then manufacturing lines are expensive to build and slow to scale. So like I mentioned previously, glove manufacturing lines are very different than what would be, a mask manufacturing line, for example, much smaller. A glove manufacturing line, it may span a football field in length and go 3 different levels of a football field. So just to put it into perspective on how big a glove manufacturing line is, it takes a lot of real estate and a lot of financial investment to put a glove manufacturing line into place. And to keep that running at an efficient level, you need to make, a lot of the same type of glove, which makes it really hard to source from a single US manufacturing source that doesn't manufacture, like I said, thick gloves, thin gloves, EC, all the different types of basket gloves that you need in a portfolio at a hospital. So buyer considerations, it can be reliable. Obviously, you're getting lead time advantages from sourcing domestically, but you're often paying more for what is the same, if not inferior levels of product quality because of the lack of experience. But obviously, you do gain some logistical advantages. Not enough capacity, like I mentioned, to support national demand alone, even if a small portion of the US were to shift heavily to US domestic manufacturing, it would not be able to support that demand. And then most vendors are promising US made. In certain cases, there are more or less raw materials going into the inputs of these gloves. But for the most part, from what we've seen, a lot of the inputs are sourced from Asia and then obviously assembled and manufactured. The gloves are dipped in the US. So make sure you pay attention to actually how much of the glove is being manufactured in the US if you are looking in that direction. Market data. So this is just a quick couple slides to show you how this has shifted. And what the capacities look like by country. So the orange shows standard capacity and the purple shows pandemic flex capacity. So you can see during the pandemic, Malaysia and China held a lot of the production and had to flex quite a bit to support a lot of that. So billions of gloves, this is in billions of gloves. So you can see how much these countries needed to flex to support the demand of the healthcare systems and why it's important to have, a diversified sourcing strategy in terms of emergency flex capacity. Because obviously certain countries that manufacture gloves can only flex so much based on their manufacturing capabilities. And then last slide here. So US glove imports by country. So this just shows how this has shifted with tariffs. Orange is 2024, purple is 2025, January to June. So you can see that China dropped significantly because of the increased tariffs on Chinese products. What the result of that was a lot of that shifting into Malaysia, Thailand, Vietnam, Indonesia. So a lot of that Chinese glove volume has shifted into Malaysia. Overall, a lot of these countries are really good at manufacturing gloves. I would say none have significant quality advantages. Malaysia has the most experience in manufacturing gloves over the last few decades, but that is basically how that's shifted. So I think we're in a fairly decent place in terms of quality gloves entering the market. But like I said, very important to have diversified sourcing strategies because this is how quickly things can shift from a sourcing perspective. So with that, that's the end of our scheduled content. I will pass it back to Bill and just see if we have any time for questions here. I know we're running a bit tight on time, it looks like, but we'll try to get a couple in here.
Hey, Justin, I think we do have time for just a couple.
Okay.
First of all, thanks for your presentation and your time and your preparation. It was outstanding. I'm really glad you're on our team. It makes me feel good, right? So we've got 3 here that I just want to rifle at you. I think you covered some of this, but still, it's good. What are the most common glove-related compliance or performance issues seen in a clinical setting, and how could they be avoided?
Yeah, that's a good question. I'd say from my experience at the clinical level, is definitely people focus on glove ripping. Something I've learned over, and part of the education in this is knowing where the gloves are thinnest and thickest, I'd say is important. So a lot of the education we do is when you're donning a glove, like I mentioned, when they're manufactured, they're dipped fingers down. So the cuff ends up being the thinnest part of the glove, moving towards the fingertips. So pulling right from the bead of the cuff of a glove is actually the worst part to pull from the glove. If you can just give yourself a bit of an advantage, sticking your thumb, a little bit further, not necessarily all the way into the palm, but just a little bit down, pulling from there and then letting the cuff fall onto your wrist is a much better way to don a glove and reduce the amount of ripping that happens and usage at the end of the day.
Awesome. Thanks for that.
Yeah.
With there being multiple suppliers in a vendor network, is it possible to have two suppliers making the same glove? And how is quality consistency managed through this?
Yeah, great question. Something I guess I didn't touch on, but it is common. Like I mentioned, there's multiple countries manufacturing gloves, and as part of being a quality, diversified sourcing vendor, you need to have your very important products set up in multiple cases in terms of whether there's tariff fluctuations that happen. Making sure that you have certain gloves set up across different manufacturers means that you may have two different manufacturers making the same glove in practice. So ultimately, the quality of the gloves are managed through, like I mentioned, the vendor's QMS systems. So making sure your vendor has bulletproof QMS systems in terms of managing that should reduce the frequencies of any you noticing any differences between the gloves, and it's actually an advantage to have a glove set up. And that doesn't mean you'll get two different gloves every day, but we try to streamline that as much as possible. But having multiple options is critical for supply consistency and reducing geopolitical risk.
Excellent. Excellent. Let's test that big brain with maybe one more.
Okay.
How do we expect the current geopolitical landscape to impact tariff changes on gloves in the coming months? And is there anything to be done proactively by a purchaser?
Nice. Ending up with a tough one. I wish I had a crystal ball with tariffs and what's going to happen these days, but unfortunately we don't. Ultimately, what I'll say is the current landscape is very unpredictable. Obviously, there have been many changes that have happened even over the last calendar year. What we've seen is that when these tariffs and geopolitical changes happen, they're often tiered, and it's not a blanket effect in Asia. So different countries may have very significantly different tariff advantages based on U.S. relationships with government policy and certain things. So like I said, I'm going to double down on making sure your vendor has loyal relationships across different countries, different manufacturers, can reduce the risk, reduce the risk of price increases coming through. Having all your eggs in one basket these days is never a good way to source gloves. So having a diversified quality system, I'll double down on that, is pretty much all you can do. Make sure your vendors are doing their due diligence to be diversified. We'll leave that there.
Yeah, that's great.